going to go through lesson 2.1, how did I do? So I might have from the chapter 1 test, how did you do relative to your classmates? So I have 20 scores from the chapter 1 test along with their dot plot and their summary statistics, okay? So rest assured, these are not the test scores from your Unit 1 test. Yours were better than some of these scores for sure. All right, so Biff scored a 65. What is Biff's percentile? So 65 is right here, and there's 1, 2, 3 at 65 or below out of the 20 scores. When you calculate that down, 3 divided by 20 equals 0.15. So Biff is at the 15th percentile. And so what that means is 15% of the people did worse than Biff, the same as Biff or less, and 85% of the people did better than Biff, is really what that's saying. Okay, so was Biff above or below the mean? By how many points and by how many standard deviations? Okay, so let's take a look. Biff scored a 65. The mean is 80. So Biff was below the mean by 15 points. So how many standard deviations was that? So a standard deviation, according to our summary statistics, is 10, and he was 15 points. So he had one whole standard deviation and half of another. Another way you can kind of look at this is if you took the points and divide by the standard deviation, it tells you how many standard deviations it is. So he was 1.5 standard deviations below the mean. All right, but that's what Biff did. What did Marty do? Marty scored an 88. What is Marty's percentile? So an 88. So when I look here, and if you're having trouble deciding what these numbers are, go back and look. There's an 88 and an 89. So this one right here is your 88. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 16 of the 20 people scored the same as Marty or less, which equals 0.8. So Marty is at the 80th percentile. Okay, that means he did the same or better than 80% of the people. Only 20% of the people did better than Marty. Okay, so was Marty above or below the mean, and by how many points and by how many standard deviations? So pause the video and see if you can answer this question. Look at question 2 above to kind of help you. All right, so Marty was 8 points above the mean, and to calculate his standard deviation, we took that difference and divided by 10, and so he was 0.8 standard deviations above the mean. All right, so let's kind of formalize some of this, get a different color to write some notes here. First, let me remind you what a percentile is. All right, so a percentile is a percent of value strictly less than or equal to a given value. So our given value for Biff was 65, and for Marty, our given value that we were talking about was 88. Okay, so Biff was below the means by 15 points, and he was 1.5 standard deviations below the mean. So the standard deviation is something we call a z-score, and his z-score was negative 1.5 because it was 1.5 standard deviations below, making it negative. Okay, so if it's below the mean, you're going to have a negative z-score. All right, and then we had Marty here who was above the mean. He was 0.8 standard deviations above the mean. So his z-score was a positive 0.8. So if it's going to be above the mean, you're going to have a positive z-score. So you can tell by somebody's z-score if they're above the mean or below the mean. So a z-score is defined as a number of standard deviations above or below the mean. It helps you understand a relative position. Okay, so a formula for calculating a z-score. You actually just did this pretty much in your head, but let's put some words to it. So this is on your formula sheet. To find a z-score, you took the value that we were interested in, Biff or Marty's score, and we subtracted the mean from it so we could find out how far above or below the mean that they were, and then we divided by the standard deviation. Okay, this is the formula for calculating a z-score. We're going to use z-scores a lot pretty much now until the end of the course, so this is definitely one of those topics that you want to know how to do. So Goldie scored a 98 on the Chapter 1 test. I want you to find and interpret his z-score. So interpret, what did we do up here when we talked about what does it mean? So go ahead and pause the video, find and interpret, and then let's do a comparison to see how you did. All right, so here's what I've got. You should show your setup. Always in AP Stats, you want to show where your numbers come from. So the z-score was the value we were interested in, Goldie's 98, minus the mean divided by the standard deviation, and I got a z-score of 1.8. What that means is Goldie's Chapter 1 test score was 1.8 standard deviations above the mean. Now, has anybody figured out what movie these characters are from? And more specifically, what job was Goldie going for in this movie? We'll come back and visit this question later. All right, so there were two mathematical operations that we used when we calculated the z-score. The first thing we did is we took each score and we subtracted it from the mean. And remember, the mean was 80. So what I want you to do is I want you to take each score and subtract 80 from it and put the difference in these boxes here. Okay, so what we're going to do is we're going to take the original score and you're going to make a dot plot for it right here. Then we're going to take these differences and we're going to make a dot plot for them here. Before you make these, I want you to keep in mind what you're going to pay attention to shape, and you're going to pay attention to center, and you're going to pay attention to variability as you're making these. So just keep watch on them. All right, so let's take a look at our dot plots. So here's the original dot plot of our data, and then we took our data minus the mean. Now, what happens to the shape, center, and variability when you subtract the mean from each score? So when I look at this one, and then I look at this one, I notice that the shape remained the same. It looks like here, this one is centered around 80, because that was our mean. This one's centered around 0. So it feels like the whole thing shifted left 80. And then our variability, well, let's see. We went from 61 to 99, so that had a range of 38. And we went from negative 19 to positive 19, which had a range of 38. So it looks like our variability remained the same too. Okay, so what that tells us is our new mean is 0, and our range is the same. Okay, so that was the first part of it. That's what we did originally when we were asking, you know, how many points above or below the mean were Biff or Marty or Goldie. Then we want to know how many standard deviations above and below the mean they were. So we took the score minus the mean, that difference, and then we divided by the standard deviation. Okay? And so in this case, the standard deviation is 10. What I want you to do is I want you to take each of these differences that we found by subtracting square minus mean and divide them by the standard deviation and put their differences here, and then make a dot plot of them. All right, so here we have our differences divided by 10. We have our dot plot. So what happened to the shape, center, and variability when you divided by the standard deviation for each value? So the shape looks to be exactly the same. So the shape remained the same. And then our center, when we did square minus mean, it was centered at 0. This one is also centered at 0, so it looks like the center stayed at 0. Okay, and then the range, so the range, this is negative 1.9 to positive 0.9, so that range equals 3.8, so the range decreased. All right, so shape remained the same, yes. The center remained at 0, yes, but actually what happened was we took whatever that shifted number was and we divided by 10. It just so happens that our shifted number was 0. So when we divided by 10, we just stayed at 0, okay? And then our range, we took our original range, which was 38, and we divided by 10, and we got our new range, okay? And then our standard deviation, our original standard deviation was 10, and I divided by 10, and that gave me a standard deviation of 1. Okay, so let's kind of summarize this down. If you add or subtract the same value A, and if you want, you could put quotes around that, A to each value, you're just adding or subtracting the same number, what is going to happen? So if you add or subtract the same value A, the shape remains the same, the variability remains the same, and only the center is going to shift positive or negative, whatever the value of A. What if you multiply by or divide by the same value B to each value? The shape will remain the same. The variability, range, standard deviation, multiply or divide by B, whatever you did in the original change. And your center will also multiply or divide by B, okay? So what is the mean and the standard deviation of a distribution of z-scores? That's this whole thing we just worked through. Will this be true for any distribution of a z-score? So we got a mean of 0 and a standard deviation of 1 when we did all of this work. Now, will this always be true? Always. Always. How often? Always. So this is called a standardized score. And it always has a mean of 0 and a standard deviation of 1. Okay, so what are your big takeaways from this lesson? 1 is your standardized value, also known as your z-score. Okay? To find a z-score, you take your value of interest minus the mean and divide by the standard deviation. To interpret it, because I am going to ask you to interpret it, you're going to take whatever the context is. So tell me what the problem is actually about. Is whatever your z-score standard deviations above or below the mean. Okay, so don't write above or below. Tell me it's above or tell me it's below. So you want to make it all in context for this situation in particular. Your other big takeaway is given any list of numbers, okay? If you add or subtract the same value to each number, the shape and variability remain the same, and the center shifts plus or minus by your A value. If you multiply or divide the same value to each number, the shape will remain the same, and the center and variability are multiplied or divided by B, whichever one you did. So always your shape does not change, but your center can and your variability can. All right, so when next time we talk, we'll go over this check your understanding. We'll do a quick review for a quiz, and then you have a quiz on percentiles and these transformations. All right, see you in class.